multiplying, dividing, and then we're going to talk a little bit about composition of functions. So the first thing that we have is we're going to discuss function operations. And basically, when you see these symbols, you have to know what the question is asking. I oftentimes will have students try to ask in the middle of a test, what am I supposed to do for this question? I cannot help you with that. That is something where if you see this notation, you have to know what it means. So we're going to start off easy. The first one is f plus g of x. So when you see this notation here, all that means is we are going to take the function f of x and we're going to add it to the function g of x. So in this particular question, they gave us two functions to work with. They told us f of x is 3x minus 5 and g of x is x squared plus 1. So all we have to do for question 1 is take these two equations and add them together. Now, if you have terms that look alike, you are going to combine them. They have to look identical. X squareds with x squareds, x's with x's, numbers with numbers. You can't just combine different things together. So I'm going to go ahead and I'm going to write out what I'm looking at. I'm going to take 3x minus 5. I'm going to add it to x squared plus 1. For addition, the order you put things in does not matter, so I'm just going to leave it alone. The only two things in this problem that can be combined together are the minus 5 and the positive 1. Now, for the most part, we don't require that you put things in a certain order, but a lot of the time what you'll see is that standard form for a quadratic. And just to kind of remind you of what that is, standard form is going to be y equals ax squared plus bx plus c. So typically when you write these equations out, you write the term with the highest exponent first. So in our case, we have 1x squared, we have 3x, and then if I take negative 5 and I add 1 to it, what do I get? Negative 4. Wonderful. Okay, now for the second part of this, sometimes when you see the notation f plus g and there's a number next to it, all this is telling me is when I get my final equation, I'm going to go in and I'm going to plug in x equals negative 6. So there is a difference between what you see on the left and what you see on the right. On the left-hand side, the way these are written, we want equations. On the right-hand side, we want a number answer in the end. So you can technically do this as two separate things. You could go in and you could find f of negative 6 and you can find g of negative 6 and you can add those together. You also, if it's a problem where you've already found what those two things added together are, you can just plug into that equation. So since I already created f plus g of x, I'm just going to take the equation I have, and in the x parts, I'm going to plug in negative 6. Now, even if you did this as two separate operations, f and g, and then added together, we should still get the same answer in the end. So what is negative 6 times negative 6? Positive 36. What is negative 6 times 3? Negative 18, and then I have minus 4. So really, I'm looking at 36 minus 22. And what is 36 minus 22? 14. And here, my friends, is my gentle reminder of you will not have a calculator. So you do have to know how to do your simple calculations. And again, I will preface this by saying, we're not going to give you really big numbers. We're not going to give you anything crazier than this, but you have to be able to add and subtract numbers successfully. Otherwise, this goes a little wrong. Okay, now let's go to our subtraction. In this problem, I am going to be doing f minus g of x. Now, this is going to require that you pay attention to the order that your problem is written in, because when I subtract, that subtraction is going to distribute. So I'm going to write this as 3x minus 5, but just to kind of illustrate that idea, I'm going to do minus x squared plus 1, but I'm going to keep the x squared plus 1 in parentheses for now. The reason I'm doing that is because whenever you subtract, that subtraction is actually going to distribute to anything that immediately follows. So a lot of people will know, okay, the x squared is going to be negative. I know it's subtraction, but they'll forget to actually distribute it to the 1 as well. So really, what we're working with is 3x minus 5 minus x squared minus 1. So whenever you do subtraction, I'm going to make a little note just so you don't forget. Don't forget to distribute the negative. Biggest mistake I see across the board is a lot of people will forget to distribute that negative to the second term. And then once we have that, we combine any like terms that we have. Again, we can combine the minus 5 and the minus 1 together. I still write things in standard form. That means the x squared term is going to go first, the x term goes second, the constant goes last. So if I wanted to subtract these two equations from each other, this is what I should end up with in the end. Now, one thing I want you to be very careful of is the negative is not technically being squared. If the negative was being squared, there would be parentheses around the negative x, and there's currently no parentheses. So when I go and take my equation and I'm subbing in x equals 4, I have to make sure that I recognize the negative is not being squared. So by that, negative 4 squared plus 3 times 4 minus 6. Another common mistake that we see is people will put parentheses around these two things together, and they'll say negative 4 squared is positive 16, which if there were parentheses, that would be true. Negative 4 times negative 4 is positive 16. But because the negative was not written in a way where it's included and it's being squared as well, you have to think of it like negative, and then the 4 squared itself is still giving us 16. So this one is going to stay as negative 16. Does that make sense? Do we understand that idea? If you don't see parentheses there, don't put parentheses there in your brain. If they're not there, we write them there on purpose when we want you to know that that negative value is turning positive. If they are not there, don't assume that they are there. Okay, plus 12 minus 6. So really, I'm kind of looking at negative 16 plus negative 6. What's negative 22? Right? Plus 12? Negative 10. Now, I try, when I'm doing this, to combine all my negatives together and all my positives together, and then that's what I simplify in the end. If you want to take it in different parts, so I have some people who might do 12 minus 6 is positive 6, and then add that to negative 16. However your brain breaks up that addition and subtraction is completely up to you. But I usually try to combine all my negatives and combine all my positives and then do one combination of the two of them. Okay, so we've done addition, we've done subtraction. Let's go in, let's do some multiplication. So in this case, we are going to take f of x times g of x. Now, this one is going to be a little bit interesting because we're not just going to combine like terms. This is where you're going to go in and you are going to double distribute. So my two equations are, I like to write them in parentheses, and then I kind of go in and pick and choose what combinations we're going to have. So I have 3x minus 5, and I have x squared minus 1. So A lot of you have learned it by double distribution. A lot of you have learned it by FOILing, first, outside, inside, last. Some of you may have used the box method in middle school. Personally, I've never used the box method, so if you ask me about it, I don't really know it 100%. But in the, is it a plus one? Thank you. I thought about it as soon as I wrote it down. However you decide to multiply these two things together is completely up to you. If you and your middle school teacher taught you how to double distribute with the box and you know the box and you can do it in your sleep, don't change your ways and do it the way I'm doing it just because that's how I do it. So I'm going to go in and I am going to color code some things just so you can see. Double distribution basically means everything is going to get multiplied. So what is 3x times x squared? 3x squared or 3x cubed? 3x cubed. X times x squared is going to give me x cubed because you're adding the exponents together. And then 3x times 1 is just 3x. And then we're going to go and distribute the same way, but from the second term. So I'm going to do negative 5 times x squared, negative 5x squared. And then I'm going to do negative 5 times 1, which is going to be negative 5. Usually in these cases, if you have something where you can combine like terms, you should. Because we started with an x squared to begin with, all of these terms actually look different. So technically you could box it the way it currently is, and that would be your final answer. I still like to put everything in order. So I'm actually going to make my 5x squared term second, because it's usually going to be in descending order of exponents. So exponent 3, exponent 2, exponent 1, constant. And we have our final answer. Now for number 6, all this again, if you see a number here, all that's telling you is to plug in whatever number they give you. They're telling us to plug in number 2. So I'm going to go in 3, 2 cubed minus 5, 2 squared plus 3 times 2 minus 5. Now, anytime you cube something, that means you are multiplying it times itself 3 times. So 2 times 2 times 2. What is 2 times 2 times 2? 8. So I'm going to have 3 times 8 minus 5 times 4 plus 6 minus 5. So just to simplify this again, I'm breaking this down as much as I possibly can. 24 minus 20. And then I'm going to go ahead and combine that 6 and that negative 5, and I'm just going to say plus 1. So what is 24 minus 20? 4. And what is 4 plus 1? 5. So we get 5. Now, again, I will say this. If you did not have a problem where you had to find the equation first, so I did find the equation first in number 5, so I used it in number 6. But if I only had the question 6, I could take 2 and plug it into both of these equations separately, multiply those two numbers together, and I should still get 5. So if you only have problems where you're plugging in the number, you don't necessarily have to find the operation first. But just to make it easy, that's what we're doing. Okay, f of x and g of x are being divided. Now in this case, because we haven't really talked a ton about factoring, and technically this one wouldn't even do anything if we factored it anyway, the only thing we can do is write them as a fraction. Now, I'm going to get the question of, can I simplify the negative 5 and the 1 together? The only time you can simplify in a fraction is if every single term has something in common. So if all of these terms were divisible by 5, yes, you can simplify that 5 out of there. But because I have a 3, a 5, a 1, and a 1, I can't do anything. So this is going to be our final form. And a lot of the time with the division one, you can't necessarily go further just because of the nature of how they end up looking. So now I'm going to go in. I'm going to plug in x equals -3. So 3 times -3 minus 5 over -3 squared plus 1. Now here is the teacher part of me that's going to look at your tests in 2 or 3 weeks. I would show all of your work. I know that you want to do a lot of this math in your head and you want to plug all of these numbers in your head and just write out your answer. I cannot give you partial credit if I don't know that you at least knew to plug in -3. Something may have gone wrong in what you multiplied, but even if I look at your work, and this is going to be wrong, so don't write it, and I see that, okay, maybe they wrote 9 minus 5 on top because they forgot that the 9 was negative. I can take off half a point for that, but if your answer is the only thing that's there and it's wrong, you're losing all credit for that problem. So go in, write as much work as you possibly can, because that is when I can come in and say, you get a half a point for that. You get a point for that. Oh, they just forgot the negative. That's why they got this number. I can't figure that out if I don't see your work. So write everything down. So in this case, -9 minus 5 over +9 plus 1. So we're going to get -14 over 10. Now, whenever you get a fraction and you start to see it, we don't make you turn this into a decimal. If you wanted to, you could, but you don't have to. If you have something where you can simplify the numerator and the denominator by the same term, we will expect you to do that. So 14 and 10 are both divisible by 2. So I'm actually going to write this as -7 over 5. So if you get something like 2 over 4, you need to simplify it to 1 over 2. If you want to convert it to a decimal, you can, but if that decimal is wrong, we technically have to mark it wrong. So usually we say, leave it as a fraction. Okay, do I have any questions on the operations part of things? Yes, Ite.
Like, I know you can go up to the number 5. You have to write factor to get to that form we just had.
Mm-hmm.
Did we learn that today? Or
Not today. You're not going to learn how to go backwards today. We will next week. No, maybe on Friday. We will this week. Thursday. Okay, next part. Composition of functions. So that was addition, subtraction, multiplication, division. Composition of functions basically means we are taking two functions and we are combining them together by plugging one function into the other. So this is always kind of like a weird idea for some people, but essentially what's happening is we are going to give you notation, and the notation is either going to look like the left-hand side where it's f of g of x, or the right-hand side where there's a little open circle f of g of x. But these two things, no matter which way you see them, they are the same exact statement. And what this means is you are going to plug in g of x for x in f of x. So everywhere you see an x term, just like we did in the other problems just now, we plugged in numbers where those x's were. Instead of plugging in a number, you're plugging in an equation. Now, a lot of it is going to simplify very nicely, and it's just going to cancel each other out. But some of it you will still have to distribute and combine like terms. But generally, for the most part, we kind of tell you what to do. We tell you what function to plug into the other, and we usually pick it in a way where it's going to work out nice. So in the composition of functions, we're going to try one out first. I'm going to color code just so you can kind of see what's going on. I have f of x, I have g of x, and we are asking that you take the outside function is always the function you see first. So if I read that problem, it says f of g of x. that means my outside function is f. That is the one that I will be plugging into. And what I'm plugging into it is going to be function g of x. So stay with me, stay with me. So now I'm going to go in. I'm going to say f of g of x is going to be equal to. This is the way I do it, even as your teacher who's done this for 9 years. I will take my outside function, and everywhere there is an x, I put a really big parentheses. So there is an x that is being squared. So in that place of where the x is in that function, I put parentheses. I like to put the big parentheses so I know something big is going in there. And that is going to be function g of x. So I'm going to take the entire function g of x. Don't make the mistake of actually including the g of x part. I'm just going to take the square root of x minus 2, and that's what's going in the place of where the x would normally be. So I'm going to have square root x minus 2 in that place. Now, whenever you do this, there's usually some simplification that can happen. What happens when I have a square root and I square it? They cancel out, right? So this square and this square root cancel each other out. So I'm left with 2, don't lose the parentheses yet, minus 1. And so simplify as much as you possibly can. If I have a 2 at the front, what does that mean I'm supposed to do? Distribute. So this 2 is going to distribute to the x, and it's just going to distribute to the negative 2. So I'm going to have 2x minus 4 minus 1. And any like terms that you can combine together, you should. So I'm going to end up with 2x minus 5. F of g of x. Now, one thing I'm going to point out before we talk about domain and range. Notice there's a difference. Look at the open circle that we have in composition of functions. That is different than the closed circle you have in multiplication. I have graded many tests where we have had the notation be f of g of x with the open circle, and people still multiply. Do not make that mistake. Open circle is composition, closed circle is multiplication. Yes, Ite.
What does that f of g, what does that mean?
That is the same thing as it's telling you what function is on the outside and what function is on the inside. So the first function you see is the outside function. The second function you see is the inside function. Generally, yes. So just a little note to show you, you could also see g of f. Let me make it a little bit open. G of f of x. And that would mean the outside function would be the g. So depending on which one you see first, that's the one you're plugging into.
So open circle is composition while closed circle is multiplication.
Correct. Okay, now the next thing. Sometimes we will ask you to state the domain. Whenever you state the domain, there's 2 things you have to identify. You have to identify the domain of the inside function and the domain of the composition of functions. And then the more restrictive one gets picked. So I'm going to make kind of a little box around here just so we can talk about it separately. The domain of the inside. In this case, the inside function is going to be the square root of x minus 2. So transformation-wise, because again, I told you transformations will show up for the entire year. I have a negative 2 inside of a parent function. What is that doing shift-wise? Where am I moving to? Down to, right to, which one?
Right to.
Inside is left, right. So it should be right 2. So I am moving right 2. Now, The parent function for a square root. You should know what the parent function of a square root looks like because we took a whole test on it. And I told you, you would have to know these for the whole year. But the parent function of a square root normally looks like this. It's a little one-armed guy. It's been moved to the right 2. So the domain of the inside function is going from 2 to positive infinity. Because it moved right 2.
What if there's 2 numbers?
What do you mean there's 2?
What if there's another number with the x minus 3?
Like inside or outside? Then you would combine those 2 numbers together. Say that one more time. This isn't fair that you are responsible for knowing information that you've learned in this classroom. Doesn't sound fair to me.
Exactly.
As a teacher who's taught you this, who told you you had to know this. No. I can tell you it's going to be here till May 27th, last day of school. It's 22nd. Maybe it's the 22nd. One of those days. Okay. Domain of the composition. The composition is 2x minus 5. What type of function is that? Ooh, is there a squared there? I'm right. It's a linear. What is the domain of a linear function? Infinity. Just infinity? Negative infinity to positive infinity. Why is it infinity again?
Because it's all of them.
Because it's all of the numbers. A linear function is not restricted at all. So whenever you have a linear function, your domain and your range, both of them, are always negative infinity to positive infinity. So looking at the 2 that we have, which one is more restrictive? The top one. So my domain is going to be from 2 to positive infinity. We want the more restrictive one. Because it says to pick the more restrictive one. It says pick the more restrictive one. Now, okay, let me talk. Whenever you have 2 graphs and one of them has restrictions, that means there are numbers on the number line that equation does not work for. So when I have numbers where this equation does not work, that's going to create undefined values. You don't want undefined values in your final answer, which is why you are picking the more restrictive one, because that tells me from 2 to positive infinity, it is going to work for the whole thing, because it also depends on what am I plugging in to begin with. So you're always picking the more restrictive domain. Now I'm going to tell you this. This is going to be dependent on you knowing the domain and range of your parent functions. So if you have forgotten them, you need to go back and you need to study them, because you have to know them as well as transformations that will change them. So this is still stuff from Unit 1. I told you guys you are responsible for remembering that. You have to know your Unit 1 information. Okay, let's go to the back.
Are you sure?
Okay, graphing wise, I have 2 functions. I have f of x. I have g of x. We will tell you which one is which. We will label them. They will be there. It's not a guessing game. Now, for a, the notation it's telling me is I am taking f of 3 plus g of 3. So I need to go and be able to read a graph and figure out what are the y values associated with these particular x values. So for f, we look at graph f. We look at where x is equal to 3. Is x the horizontal axis or the vertical axis? The horizontal. So I'm going to go to where x is equal to 3, You're going to go up until you see where the graph is. And you're going to ask yourself, what is the y value of where that point would be? So what is the y value of when x is equal to 3? 1. So this is going to be 1. And then we do the same thing. We do it for g. So I'm going to go to the g graph. I'm going to go to where x is equal to 3. I'm going to go up to where I see my graph, and I'm going to go over and see what the y value is associated with that. 4. So I'm going to have 4. And what is 1 plus 4? 5.
That easy?
It's that easy. Hold on. Yes, Jaden.
What if the GX, what if both the line up?
What do you mean? We'll get there. We'll get there. Yes, Ava. You go until you see the graph. Where the graph line is.
So you start on the graph?
I mean, you start at the x-axis and you find out where the graph is. We'll talk about multiple situations in just a second. You should only be hitting the graph once. Okay, let's try it again. B. B is multiplication. F of 2. G of 2. So we're going to go to our F graph. We are going to go to where x is equal to 2. You're going to go to where you see the graph. I will tell you this. You're only going to see it once as a closed circle. You always pick the closed circle one. So in this case, what does my y value equal? 2. Because I'm going from, just again, x equals 2 to figure out what the y value is. Okay, second graph, we have g of 2. So I'm going to go to graph g. I'm going to go to number 2. Now, whenever you go, this is the situation where you have two things to consider. Do we pick the closed one or do we pick the open one? The closed. So in this case, my y value is going to be 3.
Wait, is the whole thing not a graph?
Is the whole thing not
What do you mean the whole thing is not a graph?
Until you see the graph, but the whole picture's a graph.
The line, the graphed line, the graph. It's not always a line. Because the open circle is like a does not exist. Because that's the only place where that line is x equals 3. Until you get a plot on the line, yes. 2 times 3 is what? 6. Okay. We should, as people in Algebra 2, know how to read a graph. We should. We should. Okay. Now, composition. So, whenever you have a composition problem, you start with the inside first. So that means the first thing I'm going to find is f of 3. That's the first thing I'm going to focus on. That's the only thing I'm going to worry about right now. We found f of 3. What did we say f of 3 was? 1. Okay. Once you find the inside, I will not talk over you. Once you find the inside, you take the number that you found, and it's going to replace whatever was inside to begin with. So since I said f of 3 is equal to 1, I'm plugging in 1 to that equation. And then I'm going to go to g, and I'm going to figure out where x is. And Wyatt, what did you say it is? 4. So I'm going to go, just to show you what I'm doing, to g of 1. And then I go up until I see the graph. And then I figure out what the y value is. The y value is currently 4. Okay. Inside first, and then the outside. Last one. First thing I'm going to find is G of 3. So I'm going to go to my G graph. I'm going to go to where x equals 3. I'm going to look at where do I see the graphed line, and I'm going to figure out what y value is associated with that. It's 4. So that means I'm going to go back, and where G of 3 was, I'm going to plug in 4. Now that I have f of 4, I go to the f graph. I go to where x is equal to 4, and then I go up to my line. Now, what do you think happens if the only point I have is an open circle? Do I have an open circle? Means that nothing is there. It does not exist. So do we think that we have an answer? No. So we are going to say no solution.
That would be infinity, actually.
No solution. And I'm going to make a little note. Open circles do not exist.
Would it miss any edit infinity?
No. I'm sure. Say that one more time.
What about the moon?
The middle is an open circle?
The moon.
Oh, that's a closed circle. It's a mass.
No, but not all things.
Okay. It's still there though. It's not like
Well, I know.
it still exists.
Visibly, it's an open circle.
Visibly, it's like a partial circle. Okay, last one. Please, let's get through this. Okay, it's the last problem. The more time you take, the less time you have to do your practice. And if you don't finish your practice, you have homework. Okay, so we are going to use composition of functions to check if something is an inverse. So one thing we've talked about before is inverses, zeta. One thing we've checked about with inverses is whenever we swapped x and y, we were able to solve for the equation to show the inverse relationship. Now, one other way that you can check if something is an inverse is if I do the composition of functions and I simplify everything and I end up with a single positive x, these two equations are inverses of each other. So you can do f of g of x or you can do g of f of x. I'm going to show you both ways, but both of those will lead to x as your answer. So one thing I'm going to point out, in the question, and I can tell you this exact phrasing is on your test, it will say by using composition of functions. If you come to this problem on your test and you just find an inverse by switching x and y and solving for y, you will not get any credit. You have to use composition of functions because that is the TEK. We are trying to assess, do you know how to do it? So whenever you do this, you have two options, and I'm going to split my page in half. You can either do f of g of x, or you can do g of f of x. Now, if they are inverses, they are going to both end up being a single positive x. If they are not inverses, they're both going to end up being something else. So I'm going to start on the left-hand side. I'm going to call f of x my outside, g of x my inside. Remember, I told you, when I do these problems, everywhere I see an x, I put a big parentheses. And in that parentheses is where you're plugging in the other function. So I'm going to take 1/4 x plus 1, and I'm plugging it into where that x would normally be. Now, anytime you have a number in front and you have parentheses, you should go in and you should distribute. So what is 4 times 1/4? 1. So I have 1x plus 4 minus 4. What happens to the plus 4 and the minus 4? They cancel out. So f of g of x is equal to x. If you end up with a single positive x, it cannot be negative, it can't be x plus 1, it can't be 2x, it can't be x squared. Single positive x, you say, yes, they are inverses.
Wait, can you say that again?
So if you plug one function into the other function and you end up with a single positive x, you say, yes, they are inverses. Now I'm going to show you the other direction and how it will work either way. CT, I'll answer your question in a minute. 1/4, I'm going to do a big parentheses plus 1. And I'm plugging in f of x into g of x. So I'm going to take 4x minus 4. I'm going to plug it in, and you do your simplifying. Simplify, simplify. 1x minus 1 plus 1. And we get the same 1x. So g of f of x is equal to 1x. If you end up with a single positive x, which let me add a page so I can scroll. Add page. If you end up with a single positive x, you come in and you say, yes, they are inverses. In your test, because you will have one of these problems on your test, you can choose either direction. You can do f of g or you can do g of f. Either way, if they are inverses, it will work out. If they are not inverses, it will be anything other than this. It could be x plus 2. It could be x minus 2. It could be x squared or x cubed. But it will not be a single positive x.
Like, whether they're inverse.
It has to be a single positive x for them to be inverses. It has to be a single positive x for them to be inverses. Yes, Christian. You don't have to do the other one. Yes, Wyatt. Yes, you only have to do one side. You don't have to do both. I was just showing you that both end up being the same thing, but you only have to do the left side or the right side. Yes, Leah. Basically, they're undoing each other to be a single positive x. Okay, do I have any other questions? All right, I'm going to pass out your practice.